Okay, good afternoon, everybody. Again, Michael Rothstein here, strategic partner and account executive with Appranix. On behalf of everybody here at Appranix, I'd like to thank you for attending our webinar today. This is a very well attended webinar, so thank you. There's folks from the West Coast here domestically in the US. There's folks joining us from the UK and India. So, wherever you are, thank you again for signing up, and good afternoon, good evening, and good morning to a few of you. A little bit on Appranix. We offer an industry-first cloud-native backup and recovery to restore your entire application environment, along with advanced cloud and application environment level protection and multi-region recovery. So if you're looking to achieve 50% better SLOs for your single cloud region or zone application with much better RTOs, we are focused in availability as AWS Marketplace and the Google Marketplace as well. It's a very unique solution. We will slide this over to Govind shortly, who is our co-founder and CEO, to present to you all the unique capabilities and benefits of our solution. This obviously, if you're running workloads in AWS or GCP, this is a solution that serves your cloud-enabled, where you're lifted and shift for your lifted and shift environments, obviously, as well as cloud-native applications. If you built your applications on microservices-based architecture, if you're running on containers and Kubernetes, we're a pure play in that space. This particular webinar, we will focus on why legacy backup and DR doesn't work for cloud app environments. And to get into a little bit specifics of this, bears repeating, legacy backup and disaster recovery is too complicated for cloud environments, and it just simply really does not work. Cloud environments are programmed to auto scale and scale out and in. And as you know, some of these backup and legacy tools, you need to manage backup agents and storage in auto scaling environments, too complicated. So we're going to show you and a little bit more emphasis on that. We know that legacy backup only covers around 12% of the cloud application environments. They don't cover the network security, load balancer, or serverless databases or containers. They can't recover environments with infrastructure as code. So we're going to show you how we enable that particular action, how we recover 100% of your application environment along with its services and your data. After this webinar is completed, we will be posting this on YouTube. So if you don't have a chance to view it today, or you want to view it and pass it on to some of your team members on your technical bench, that'd be fantastic. You could also go to YouTube and just type in Appranix in your browser, and you're going to see a full, complete, comprehensive library of webinars that we have sponsored, various use cases if you're running on AWS or GCP. So with that said, let me kick this over to our co-founder and our CEO, Govind Ragaswamy, and he will navigate the presentation and the demonstration of our industry-first cloud-native application resiliency tool. So with no further ado, please take it away, Govind. Thanks so much.
Wonderful, Mike. Thank you very much. I hope you're able to hear my speech as well as the slide deck, so we can get started. Thank you for joining us again, and particularly today, we are going to talk about why legacy backup and DR doesn't work in a cloud application setup. And if you are thinking of either migrating, or you have already migrated your applications, or started from scratch on the cloud platform. So it's an opportunity to drop some of the technical debt you might have had or accumulated over a period of time, and a different approach to make sure that you could achieve much better resiliency for your applications running on the cloud platform. So let's jump in. Cloud-enabled or cloud-native are the two different models that are coming up more and more as we speak within even the largest enterprises that we have seen, that we have interacted through a couple of years, and also cloud-native ones particularly growing up through the Kubernetes world more and more. So the modern application model is becoming the standard model, starting with the cloud platforms. And I think, as more and more hybrids and the edge cloud comes along, you will start seeing that same model being adapted at the edge level as well. So slowly that legacy data center model will kind of sunset over a period of time from our point of view. So you could think of legacy applications that have been lifted and shifted over to the platforms as cloud-enabled ones, because by the time you go to the cloud, you tend to kind of utilize not only the basic infrastructure services like compute, storage, and networking, and so on, but also the load balancer services, the DNS services, and variety of VPC services that are available in the cloud natively. And that makes it easier for your applications to be kind of enabled with cloud services to be available a better way compared to the legacy data center approach. And obviously, the modern cloud applications, if you're building completely from the ground up, maybe you're looking at containers as a platform for your microservices, or even macro services, meaning larger services that are simply hosted on the containers for ease of upgrade and other areas of operations, ease of operations wise. So both models are applicable in our discussions, but in both discussions, there is one element that's coming up more and more, and I'm not sure if you have seen in your environment lately, in your space, in your vertical lately, but as you can see, ransomware attacks are happening day in, day out. They are increasing in terms of sophistication, in terms of how they attack and how they kind of become dormant within your enterprise, and laid for some time until they get activated by some trigger point, and then completely occupying your entire region where you operate, or your application account completely sometimes. So those problems are occurring, and the effect of those ransomware attacks are enormous. If you think about some of the cases that have been pointed out on the national news, if you will, right? One talks about murder in the Amazon cloud. I mean, that's like a attention-grabbing type of title. But at the end of the day, code spaces simply died. They could not take any more of the the penalties that they had to pay with respect to losing people's code. And traditional enterprises like Atlanta district completely went through the attack, and the recovery took close to $2.6 million and over many weeks, as opposed to the ransomware payment itself is like $52K. So this is really, it's becoming more and more sophisticated, and that is where your approach with respect to resiliency, as opposed to traditional backup and DR, has to be different. And that is not only because of just the ransomware attack, but overall, if you think about a cloud operations model versus a legacy operations model. When I say legacy, the data center model is one of the approaches, but a traditional operations model, if you will. When you go to the cloud, it's better to go with an infrastructure as code model, right? Because it's consistent, it's controlled, and also rollback is possible. When you outsource your infrastructure deployment to, let's say, an AWS or GCP platform, they handle all the deployment for you, right? If there is a problem in terms of not able to provision a particular workload or a VM, there is a possibility to roll back without affecting your existing production environment. So that offers tremendous benefit in terms of not only reducing the errors, manual errors, but also an incremental versioned approach to your infrastructure. So it's better to code, but even if you haven't coded, we will show you a mechanism for you to kind of automate that using the resiliency approach, the cloud application resiliency model, as opposed to the traditional model, legacy model, where you end up provisioning your infrastructure on demand, either through manual provisioning or through scripts and through wizards and so on. So that approach is outdated to your point. Second problem, a second model from a cloud operations perspective, auto scaling of VMs, right? It's not only just scaling of VMs, as Mike mentioned, scaling out and scaling back in. That is one of the benefits that you get, because once you code it up, once you kind of put the policies in, you are scaling out your VMs. But also there's a potential to increase or dynamically scale your storage, right? Attach new EBS volume, so easy compared to the previous one where you have to go and mug around with your storage systems, over provision the storage systems so that you bring back that particular volume that needs to be attached to a particular VM, or maybe even to an ESX host, so it can carve out more of the storage from the ESX host. So that difficulty in terms of scaling the storage, right, has been simplified tremendously in the cloud operations model. And similarly, the networking features or capabilities has tremendously changed as well. So cloud operations model pretty much introduces that the dynamism into your infrastructure, right? As opposed to the manual scaling, semi-automatic way of doing things with a legacy model, and where approvals are required. Even if the new model, maybe you are using approvals, but even then the dynamism is real and it is possible. Third, that what we have noticed is that particularly when you go over to the cloud-enabled approach, use of cloud services more and more approach, compared to the legacy model where the load balancers are of limited use, maybe at the application HTTP session level, right? Whereas in the cloud operations model, you have like 2 different load balancers or 3 different load balancers for you to take advantage of. You could spin out load balancer at the basic infrastructure level and also at the platform level, right? And it comes in handy, particularly when you deploy your applications across multiple zones. Multiple zones pretty much, enables you to deploy 2 different data centers hosted within the same region, right? Whereas if you go to your traditional model, it becomes a single data center. You're spinning off that load balancer product that you have installed and managed in a shared services fashion to make use of the infrastructure within that particular data center infrastructure, right? And the fourth one that we have seen is that more and more cloud-enabled applications are using cloud-based database services, mainly because nobody wants to deal with this every month update of the security updates for the databases, and version changes, upgrade, all of that is taken away when you use cloud-based database services like RDSs from AWS or Cloud SQL or similar services elsewhere as well, as opposed to self-managed databases where you're comfortable with it because you have been doing that for a while, and the changes have been occurring over a period of time. You have added agents for various purposes, including a database backup and so on. So at the when you move to the cloud pretty much enables you to think. Or some of the customers have actually literally asked us, can it be always on? Can I have my applications to be always on or closer to always on, right? To achieve a better resiliency. By the way, the backup and DR needs to be built in. They don't want to lose that. So you got to have backup and DR because you need to have compliance, and in the case of a failure, you should be able to go back. But also, bring me to that always on. Bring me closer to the HA, right? Some of them are pushing for not only active, passive model, active standby model, right? Moreover, kind of an active across the region as well. So they are pushing the boundaries, and they are able to push the boundaries with cloud platform as opposed to traditional model where if it is broken, right, don't break it. Just continue to kind of modify slightly here and there. You're building the technical debt, but that is okay because, why break things if things are not broken, right? That model is totally acceptable, totally understandable. But when you go to the cloud, make sure that you could at least drop some of the technical debt so that you can think broadly and think in terms of bringing that to the next level. Right? When you think about kind of the newer model, right, achieving cloud application resilience as opposed to the backup and DR, which is almost like an infrastructure speak, right? When you are not dealing with the infrastructure, when you go to the cloud, why talk about the infrastructure at all, right? You have to really think from the cloud application resiliency perspective. So even when you from a resiliency in terms of risk reduction perspective, right? Overall, think about it. But cost reduction is tremendous as well, right? When you bring the legacy, backup solutions over to the cloud, typically wastage in terms of dollar-wise is almost like 35%. Based on a real study that we have done with a real customer, enterprise customer, who's running about 300 terabyte of data across their 400 virtual machine environment. They are spending X amount of dollars, and out of that, 35% of that is literally going into the backup and recovery of that set of applications, around 180 applications. And it is too complex because, I will explain and go into the details of what it is. It's too much manual stuff, too complex in terms of dealing with agents and so on. Even with all of that, the coverage is only 12% of the application environment. Right? Think about that. So you're doing what you have been doing, and you pretty much adapted the same model and approach and product, all of that for your backup and DR, and you get less coverage, right? And that doesn't seem all right, right? So and moreover, when you get attacked with some kind of a ransomware or similar cyber disasters, the legacy systems are not ready because they were created before all this ransomware came along, right? So you'll have to think about how best you could leverage the cloud platforms to your advantage, and that is where we come and help. So if you think about it, starting from the self-managed legacy backup solution, so you ported over your legacy solutions, or even trying to kind of code it up yourself. One another thing is that I can code snapshot management, and also I can code up the rest of the infrastructure services in using CloudFormation or similar ones. They are disconnected all over the place, right? So do-it-yourself backup and DR increases the risk along with your existing solutions if you're kind of managing yourself. With the existing backup solutions, you're putting agents all over the place. Think about managing agents across hundreds and 200s and thousands of virtual machines running multiple applications, hundreds and hundreds of applications, right? And you cannot even dedicate your own network adapters to shove in the traffic through that dedicated network adapter so that you can back up the solutions. Those kind of a customization of your data center is not possible on the cloud. So you end up using the production network for backup as well. That becomes too complex. You're overloading your infrastructure, right? And if you overload the infrastructure, you end up over provisioning the infrastructure, thereby increasing the cost on the cloud, right? So not only kind of introducing the congestion which affect the performance, and it decreases the resiliency, but also increases the cost. And now, if you are dealing with replication management, because you want to protect in another region, just in case if that region goes down, then you will have to manage the replication as well, right? And on top of that, your infrastructure as code, the way we understand after talking to many of these enterprises is that when you do typically lift and shift, you don't do the infrastructure as code. You want to just, shut down your data center, part of your data center, move all the virtual machines, you start operating the virtual machines as if nothing happened using the newer tools. But at the end of the day, if you have to write the new infrastructure as code, you are starting day zero, meaning that you are redeploying that infrastructure. So it becomes really hard, kind of a catch-22, if you will, right? You will have to write the infrastructure as code to deploy it, but you already lifted and shifted your infrastructure, so it's already running. So how do you go back and write it? But unless you have the infrastructure as code, you cannot achieve the efficiency that you're looking for. So that you're stuck in that kind of between two hard places, if you will, right? And how do you make use of more and more cloud services that are coming in? And how do you manage the environment? It becomes too complex, right? And that's why people do not want to even think about application resiliency to begin with, but the companies that have been operating for a while, 2-3 years on the cloud, they realize that they need to change, right? There is an opportunity, the light at the end of the tunnel to change, right? And they have an opportunity to combine the backup and DR system as opposed to two different systems before. With all of that, they can get a much better coverage. If they can get the coverage beyond the 12%, right? Where, you could even simply ask the question of, are my applications really protected with all these problems? The backup administrators and DR administrators are sitting somewhere else. They are delivering a shared service. I don't talk to them often. And their job is to make sure that, that compliance chore is taken care of. But that is not the case, because you are now operating on the public cloud shared infrastructure services model, which means that, the backup is a must. Ability to recover is a must, right? In fact, some of the organizations are now asking, can I actually, completely isolate my VPC that is running production and ship it over to some other managed account separately so that we get one more level of protection? It's going to cost more, but people are looking for it, right? And that is where we come in. How do you really deliver an application resiliency when you look at this kind of an environment? This is running, about 8 virtual machines, right? Eight virtual machines. That's about it, which are running in, 2 different zones. Or for an example, demo purpose, we spin it on 3 different zones within one particular region. And that application is running using multiple combinations of the load balancer, application level load balancer, and the network level load balancers, and combinations of the services that are kind of a firewall services, other VPC services, route tables, all of that combined. You're pretty much looking at the entire environment of a very simple application. We'll demo exactly the same application today, but this is the environment that we are going to look at. In that case, even if you have to really manually create all of this, you'll have to really know what the connections are, how dependent those connections, which connection goes where. The dependency mapping itself is hard. I don't know how many of you have really kind of looked at that application environment of yours that has been running over a period of time. And in that case, when you go and protect, when things are kind of auto scaling, dynamically adding storage and so on, how do you really take care of that? How do you really order your instances to come up and then hook back into the load balancer to bring back your applications, right? In that case, can you really automate that infrastructure as code? And what we are seeing is that actually go ahead and try it over your coffee break, literally. And we guarantee that you'll be satisfied. By the time you finish up your Starbucks coffee, you could have protected your application environment. All you have to do is to go to the AWS Marketplace, subscribe to Appranix, auto discover infrastructure, put your policies in, you will get your application environment time machine with cloud native backup, which is ready to recover at any point in time. And you could use it for multiple purposes. One of the purpose is to do a DR test, DR simulation, and so on. So we have been pushing this cloud application resiliency for a while, and people are taking notice of it. People are understanding why it is now possible on the cloud to achieve cloud application resiliency. And we have been recognized by one of the top 3 platforms by Enterprise Management Associates, and you will see a lot more endorsements coming out from Gartner and Forrester this year. And we operate as a SaaS. It's completely enabled SaaS. It can scale infinitely in terms of, you can throw any number of workloads in the back and it automatically scales, which means that we should be able to operate at 99.95% SLA. Otherwise, we end up paying kind of a penalty to you guys if you're trying out, which means that we should be using our own system. In this case, yes, we are an account in our own system, right? It runs, and knock wood, we have been running at 99.997 or 100% for the last year plus. If you think about customer-wise, an edtech company called Pragya Systems has increased the resilience by 300%. I mean, they were operating on rack space with the hosted infrastructure to begin with, and then they moved to the cloud platform, GCP in this particular case, and they have seen enormous benefit out of our system, right? And large university, they keep signing up large university systems as a whole, multiple colleges in the systems, which means that hundreds and thousands of students are signing into their application, which means that their application has to run continuously. It needs to be always on. And then if they turn back and say that, how do we actually achieve it, right? We provide a very simple solution. And if you think about peel the layers and under the hood, what's happening is that very simple. From your point of view, it would be very simple. Of course, we take care of all other complexities and hide all the complexities unnecessarily. That is not applicable from a resiliency perspective. So start from the marketplace, give read-only permission to your production. We do not alter your production environment by any means. You continue to change your production environment the way you like it, using API, using your console, using your CI/CD pipelines, you name it. You are free to go and change your production infrastructure the way you like it. You've been doing it, so continue to do that. And you can continue to, in fact, add infrastructure as code. You are free to do whatever you like. What you get is that the application environment time machine with few policies that is per your application RPO and RTO requirements, right? Or in the SRE speak, SLO requirements. So the system, Appranix, continues to learn from your production environment to bring that application resiliency and then make sure that everything else in terms of completely automating the infrastructure as code, in terms of allowing you to kind of roll back, even if some of the developers commit a mistake in terms of putting their new code in and you're not able to go back, you can do all of that very easily with Appranix. And moreover, we make it easier for you to achieve 3 to 4 levels of resiliency, depending on your requirement as well as how you want to structure your resiliency going forward. So that this level of resiliency was unthinkable, right? Or was affordable only for large financial institutions or those who had so much deep pockets. But that is not the case when you move to the cloud. So the levels of resiliency, right? 3 levels of resiliency is right within the single cloud provider, and we make it possible for you. Right? And then if you want to go another level of resiliency where you want to bring up your applications, in this particular case, only the container-based applications are applicable, you can achieve level 4 resiliency as well. So that is kind of a fundamental difference that enables you to think out of the box on the cloud, something that you can achieve that wasn't just possible before, right? You not only go to the cloud for an initial cost reduction, and of course, how you use it might throw you off with respect to your cloud bill with a shock, but that's a different issue. So initially you achieve some cost reduction, right? Because you shut down the data center, part of the data centers, you achieve that, a cost reduction. And after that, you achieve agility. So people go for agility in terms of ease of provisioning and making use of the infrastructure really quickly. You don't have to buy and wait and lead time for the servers. to be hooked up to your data center infrastructure takes time. So all of that introduces agility. That's all great. But the third pillar of the cloud is the resiliency pillar, right? In fact, that may become, or that is already becoming the most important pillar to think in terms of what you could do with cloud, right? Cost reduction, one time gone. Second, agility, you understand it. It depends on the application type, right? Some applications might need a lot of agility. Some applications, they do not change much, so why bother, right? So agility is an argument that depends on the application, whereas resiliency is a requirement, right? And it is achievable. And it's achievable to a point where you can simply embed, even if you're a DevOps-driven organization, you can simply embed into your DevOps pipelines with a single line of code into your pipeline, and Appranix will automatically take care of it, right? It will automatically create production copies that could be used for rollback, recovery, or failover, right? So people use it in all kinds of different ways. In this particular case, it's about getting rid of your legacy backup and DR, and the benefits and the value-wise, return on investment-wise. And we simply compared a very simple $50 million revenue company. It's a simple, take it with with your own thinking in terms of how many VMs that you have. The ROI is tremendous. So we can give you all the details if you want to go into the how we calculated all of that. But as you can see, the rate of return on investment is tremendous, mainly because cost reduction, and also the risk reduction. I don't know how we can quantify the risk reduction completely, but it is tremendous, right? So with that, what we could do is that we will jump on and do the demo with a practical application, as if that application has been migrated over. So to begin with, the application looks to be upside. The application looks like this. It's a open source EMR, emergency medical records application. So it's critical that this application runs for the hospitals, because I know there are a bunch of patients that need to be operated on, or various procedures and providers need to be connected to this system. So it's critical, and it is something related to the health, so human health particularly, and so it becomes mission critical as well, which means that this application has to be protected properly. In this particular case, what we are going to show how this application runs today on one of the regions of AWS. So if you think about about 8 different virtual machines hosting different components of this application, web services, database services, and application services of this application across 3 different zones on the East Coast. So you have C, D, and B hosting this application components. And that's all you see. Typically, this is what you see, right? You go into the EC2 console, you set up your instances, you make sure that they are running, they're not creating any problems and stuff like that. And you look at your volumes and your load balancers, all of the good things. Your things are running fine, and most of the time they all run just fine, no problem, because AWS has increased the resiliency of their basic infrastructure level, so totally fine, and it is running great. Now the situation is that, as I mentioned, things happen, right? Ransomware attacks, or deployment issues, or region failures, or any individual, load balancer failure in this particular case. How do you really kind of take care of that? How do you kind of roll back and then roll forward? So this is where Appranix comes in. And to begin with, it's very simple in terms of how you onboard. So to onboard, it's very, very simple. You create a cloud connection. That cloud connection, in this particular case, a test connection. So since I already created the connection, I'm not going to run through the connection as such, but I'll show you how easy it is for you to create a cloud connection to connect to your cloud from Appranix and over a coffee break. So let's drink the coffee and create this cloud connection. So Virginia is running here, and I'm going to recover to California, right? California region on the northeast coast. And you can actually add more if you wanted, and add a bunch of services and application, load balancer, classic network load balancer, and RDS, and so on. Add those services and click next. It's going to generate the IAM policies that is required by AWS. This is the recommended approach. In fact, AWS didn't even want to provide us with technical validation of our solution without the capability that the role-based access control is. So simply launch your CloudFormation into your cloud environment. In this particular case, the same environment that is running your applications on AX demo account. You simply look at your earn, and that's all we are looking for in terms of giving the option. So you simply click next. You can review all the IAM policies, go through the details if necessary. For this purpose, what we are doing is simply rolling out that particular stack. So the CloudFormation runs in terms of allowing the permission to read from your account. And if in case, if you decide that Appranix doesn't work out in this particular case, all you have to do is to remove that earn from your account. That's simple, right? And so you don't have to work hard to completely get rid of the service if you don't want it, right? We would like you to stay, but if you don't want it, go ahead and get rid of it. So for you run it for a moment, it will complete, and the output will be available for you to copy. So all you have to do is to cut and paste this on, and all that is a cut and paste and connect to the cloud, right? That connection simply gives you the connection to automatically discover all your application environment details, right? So the connection is already established, so your account is ready to go. And as you can see, all the services that you selected are already in the discovery mode. And your internet gateway services are getting discovered more and more. There you go, that's done, right? All you have done is that connect, click, and done. So your application is ready to go. All you have to do is to create a representation of your application in terms of an assembly. In this particular case, I have already created the assembly, so it's not required. In this particular case, this assembly has been created, and that has about 38 resources. Right? If you think about the assembly, all you have to choose is these 8 compute resources to create a boundary. Everything else is automatically identified. So even if you're running 140 load balancers, as in the case with one of our customers, you get only 2 load balancers for that particular application environment, right? That is all you need to protect if you have to protect this particular application and as an assembly. And then all other components of the AWS infrastructure will be automatically identified. Dependencies wise are already created. All you have to do is to key in the policy. As simple as that. So you create a protection policy. In fact, you can pick up from an existing policy template. So you click a policy template, you can do with a protection policy. If you don't like it, go to protection policy and name, and you can choose whatever that you want in respect to pushing it. So if you want to really push the boundaries, you can go up to 15 minutes as well. For some of the applications, be careful in terms of stressing AWS infrastructure too much. So we recommend 15 minutes for your most critical applications. So once you do the policies, the timeline automatically builds for you. Nothing else is required, right? This environment time machine, we call it, it's already ready. And you go into every one of these time machine elements, you'll see at that particular point in time, everything is captured. Not only your EBS volumes at that particular point in time based on your SLO policies, RPO policies, but your compute configurations as well. So at that particular point in time, you might have changed from T2 micro to something else. You might have changed the device root name to something else, right? DHCP options might have changed, or route tables might have changed. You might have introduced new route tables, all the configurations there, right? Your load balancer might be having a different HTTPS policies. all of these details are automatically identified for your application environment and ready to be recovered in the California region, including your EBS volumes with the data, right? So let's take down this application for a moment. So let's go back and to EC2 service and take down this particular application to simulate what's happening. So let's kill this application as if something happened and bring it back from the dead. So in this particular case, I have to just isolate this environment, and I'm going to just turn off the entire application here. So here, my application is not going to respond at the moment. So let's refresh it. So the application is dead. So I'm in the panic mode. What I have to do is, in this particular case, the timeline is hourly to retention. So I'm going to pick any of this. It's totally fine. So I'm going to pick one of these, go back in time, and then bring me that application with the test recovery. I'm recovering in this particular case, test recovery. It's already selected. You're in a, faster. Give me, I don't want to even type all these things. Get me my applications, right? That's it. If you're using your iPad with a VPN connection to your enterprise, all you have to do is touch, type, recover. All of that is getting spun up for you. So you could go to this region where you are looking at your application environment, Northern California region, right? Your application is going to come up, and there, once the stack is kind of automatically created here, you are ready to go. So here, your application environment is getting spun up. So you can see all the events that are kind of getting created. Your VPC, your DHCP options, and your 38 plus resources that were protected for your 8 VM environment, right? I think it's a lot more than just 38 when you spin up more and more here. So your resources are automatically getting created to a point where if you look at this code was written for you automatically at that particular point in time, right? So this environment that I showed you before is the same as the one that, so we don't just simply preach, but we actually practice. So you can see the same 8 VMs, right? 3 different zones. So you can pretty much take the entire 3 different zone-based application into another 3 zone-based application. In some regions, right, you don't get 3 zones. In that case, we would collapse into just 2 zones, make it run. But typically with AWS infrastructure, you get at least 3 zones, right? So you'll be able to run. Even if you collapse into 2, your application will run until you kind of make sure that you can spread it out appropriately based on your load balancer and so on. So even with a complexity of all this application environment, right, think about the level of code and level of configurations at that particular point in time that you have to do. So here the system automatically wrote about 2,500 lines of code, right? You didn't have to touch your keyboard. All you touched is on your iPad, that recover button. So let's look at what happened for the instances and the load balances on the recovery side. California region is coming up, so let's go to California. And here, the environment is up and running. Let's see, I think the time it takes on the AWS is so it's all getting initialized here, as you can see. All I have to do is to make sure that the recovery is complete. So it's a final stages of, I think there's the instances wise is about close to getting it done. And all your recovered resources will be listed here as well, so you can kind of open and check what those resources are. And just to make sure that you got your T2 micro in this particular case, I don't want to swipe my credit card too much. So we are using micro instances. We are spinning up across multiple regions anyway. So that is a situation when you think about, creating more and more. So you can see the load balancer is now getting created. It's all done, that as well. So your load balancer is back and with all the properties, right? With all the properties, and recovery is completed. Number 3 minutes 45 seconds. That's all you need. All I have to do now is to turn the DNS over to the other side. So here, we give you kind of a script if you want it. In this particular case, I'm asking the system to fail over. So I am failing over to California, right? So let the DNS, we are using route 53 for this DNS purpose. So it will be failed over to route DNS. You can look at the route DNS instances here with respect to what's failing over and so on. If you're free to go back to host zones and get the records that you wanted, that is global configuration anyway, so that shouldn't be a problem. Where are the host zones? Sometimes create host zones, open EMR. All of that you can see it is pointing to the external. US West is the external one app site. So the application is verifying that URL is up and running. Once it is done, it may be because your instances might be just spinning up. There is one more instance that needs to be kind of brought back. And once that is up and running, application will be running in any case. So while it is doing this, let me ask, are there any questions? Are there any questions? If there are questions, you could type it in on the chat, and you can contact us anytime, anyway, online, and you can contact Mike anytime, over the phone as well. Any questions will be answered really, really quickly. And again, you could do all of this